For decades, Britain's energy security relied on a simple, isolated model: digging fuel out of the North Sea or burning it in coal plants. Now, that isolated grid is undergoing a massive, capital-intensive rewiring. Engineers are racing to replace a century of legacy infrastructure in a single decade. The engine driving this transition is the mechanical scale of the UK's offshore wind sector: vast arrays of turbines built to master the hostile conditions of the ocean. This chart tracks the aggressive upward trajectory of offshore wind generation in the first quarter of 2026. Wind supplied 37% of the total energy mix, hitting 23,880 megawatts, while natural gas generation declined. But you cannot run a hyperconnected economy on a power source dictated by passing weather fronts. When the wind stops blowing, it leaves a massive vacuum of intermittency in the grid. Harnessing nature solves the carbon problem, but introduces structural instability. To prevent blackouts, grid operators are constructing a multi-billion-pound redundant network of firm baseload and international links. To counterbalance that volatile wind, the grid requires an unyielding anchor. Mega projects like Hinkley Point C and Sizewell C provide the rigid, engineered baseload power that runs continuously, regardless of the weather. The financial and physical scale here is massive. Sizewell C alone is a £38 billion delivery project designed to pump 3.2 gigawatts of steady electricity straight into the grid. Securing that power requires deep geopolitical maneuvering. For 80 years, facilities like the Springfield site in Lancashire have manufactured the specialized fuel required to keep the UK's reactors online. This global flow map shows how the UK and its allies are severing supply lines. Through the Sapporo 5 alliance, the UK is executing an aggressive timeline to permanently decouple its domestic nuclear fuel cycle from Russian uranium by 2028, routing connections to Canada and allied nations instead. These nuclear facilities function as sovereign energy assets, stripping away foreign leverage over the domestic supply. Balancing a rigid nuclear baseload with the fluctuating output of offshore wind requires a massive subsea web of underwater interconnectors. Deploying specialized maritime vessels, engineers have laid over 10 gigawatts of operational cable capacity across 10 different international links. Looking at this map of the North Sea and English Channel, you can see these pulsing energy pathways in action. When domestic demand spikes, the UK pulls in Norwegian hydropower or French nuclear. When the North Sea overproduces, British wind is exported directly to Europe. The next phase of this network introduces offshore hybrid assets. By inserting wind farms directly onto these international cables, operators can flow power multi-directionally, depending on who needs it most. Isolation is a liability. Maintaining the UK's energy supply now requires constant, real-time synchronization with the broader European grid. But this clean energy system is still under construction, and the physical transition is full of friction. Even with wind breaking generation records in the winter of 2026, natural gas was still required to provide over a quarter of peak electricity demand, just to prevent blackouts. The grid also relies on imported biomass, burning millions of tons of wood pellets. It is a controversial measure, but it delivers reliable, dispatchable power when other sources fall short. Decarbonizing an entire economy is a messy process. Grid operators currently rely on carbon-emitting bridges simply to survive the transition period. Yet the macro milestones show the speed of this rewiring. In 2025, the British grid operated for an entire calendar year with 0% coal generation. This area chart illustrates exactly how fast the mix is shifting. The dark gray coal band pinches out completely, replaced by expanding wind and nuclear zones that pushed zero-carbon sources to over 91% of the total mix during optimal conditions in early 2026. The 2030 Clean Energy Mission has moved past theoretical policy documents. It is a physical reality being bolted together right now. Modern energy security depends on the strength of international alliances and the massive engineering required to harness the raw force of nature.